Hi all, I'm Vijay Jethani. So in today's session, which is on OpenShift hands-on lab, we are going to cover basics of OpenShift and we will do some of the deployments. This session is intended for beginners and the intermediate audience. So let's see what agenda we have for this session. First of all, we will know through what OpenShift platform is and how it is different from others. When I say others, it is more of in terms of Kubernetes, because once we see OpenShift as a platform, the first thing which comes up our mind is containers. However, it is not just for containers, it is also for VMs. Okay, so in this particular session, we will be focusing more on containers and Kubernetes. Okay, and then we will move on to the architectural guidance. Now, architectural guidance will cover us more on what the private clouds and the public clouds will look like for OpenShift platform. Okay, so we will go through some of the architecture diagrams and how you will going to implement if you want to on your own. So that is the architecture guidance. Moving on, we will have a setup of hands-on labs. Now this is a setup which already provided by Red Hat, where you can try on the basics. Also, you have some labs which you can carry on, and there are some labs which you have to actually try it on your own PC as well. So that for that you have to install the CLI of OpenShift. Okay, so I will guide you step by step how we move on with these particular labs. And finally, as you see, like there will be lot of content which is outdated. Okay, so in that case, I in this particular session, while we do the hands-on lab, make sure you understand each and every point, because there are some labs which are quite outdated and they will not work on your machine, or they will not work on your sandbox environment. So for that, pay attention so that whichever image which I am selecting, you are also able to follow along and complete your labs. Okay. So again, this is for beginners and intermediate audience. If you are already experienced, I think this session is not for you in simple sense. It may be refresher for you, but I think uh, being an advanced or expert audience, you will not need this session. Okay. So let's start step by step. First of all, let us know what the OpenShift platform is. Okay. So first thing which comes to our mind is how it is placed in terms of the architecture, or I would say the way we see our clouds. Like, so it is distributed in layers. So if you see the bottom, you have all the physical, virtual, private, and the public. This is nothing but our infrastructure, and that is how we look it, right? Then on top of that, we have some kind of OS or hypervisor in a normal sense. Here, hypervisor or OS which we are looking is Red Hat Enterprise Linux Core OS. Okay, so this is required for our control plane. We can also have a Red Hat Enterprise Linux, but that just needed for your worker nodes when you want to implement virtual machines. So remember, here we are talking about Kubernetes as a platform, hence we have shown the layer of OS is just Core OS, because that is the only supported. And to be frank, when we say this certified means this is certified by Cloud Native Foundation. Okay, the Red Hat Enterprise Linux Core OS is certified for running Kubernetes on top of this. Okay, so now difference comes after this Kubernetes layers. That means automated operations. Okay, so what is different in this layer against what we have in our public cloud for Azure, which is hosting Kubernetes? Similarly for AWS, Google, IBM, there are n number of other cloud players which are implementing Kubernetes. So difference is automated operations is nothing but we call it a small binaries, or you can say operators in OpenShift terms, which gives us the functionality of networking, storage, and all the infrastructure required to run our containers or VMs without even touching the infrastructure. So if you have anytime done the Kubernetes installation, you know that after base installation, we need to set up the load balancers, we need to see the networking, we need to set up n number of things for getting our infrastructure ready before even we start with our containers. Okay, so that is what the difference is with the OpenShift. It gives you an automated operations. We it has number of operators which are installed from a first party. There are operators which are available in the marketplace which you can install from third parties, but the baseline is you have automated layer built in for containers, so that you can directly start from a GUI or CLI, whichever you're comfortable with, without even touching your infrastructure. Okay, now having said that, the layer above that, whatever you seeing, the monitoring, the logging, everything is so built in or baked in, you can view that again from CLI as well as from the GUI. Okay, the application services, service mesh, and the developer tools are also baked in. Like that means you are already having the tools which you are ready to install and have the container platform running and ready in few minutes. Okay, so this is the, I would say, the advantage you see with the help of OpenShift as a platform, but everything comes at its cost. So once we do the comparison, I think you will be very clear on which platform I can choose based on the pricing, based on the complexity. Also important thing is what kind of resources or constraint I have on my team. Okay, so this can be based on our expertise or this can be based on the pricing. Okay, so I will just pause here for a while, just have a look at this particular basic of OpenShift layers, and then we will move ahead. Okay, so again coming back, you have a basic infrastructure the way you have a normal your hybrid clouds. You have some kind of hypervisor which is enterprise core Linux here, and then moving on to that we have the Kubernetes installed which is certified by a cloud native foundation, and top layer is which is providing us out of box services of Kubernetes automated operations, and then above is your application layer, or for what you can say for cluster applications, whatever you want to have, you can have from marketplace or getting installed as if you are working directly on a ready made available public cloud, or I would say platform as a service directly provided to you out of box. Okay, now let's move ahead and do comparison with what we have as a part of OpenShift. Now this comparison you can think from two terms. One is think how much efforts you put in and the pricing. So let's start with licensing. So licensing, if you have want to have Kubernetes, the binary is available free of cost. Hence, you see it's open source and available. So whether you are using AWS, Azure, or Google, I think you are not paying any fees for this. But with OpenShift, it comes with an commercial licensing model because as you see this automated operations, this is which is causing this to have a licensing model, because this is built on top of to provide you a seamless services you can install. Hence this is a paid service and you have to choose accordingly. Now based on the costing, again self manage, you only need to pay for whatever the hardware you use or machines you use. Similarly is for your AKS, you pay very minimum amount per cluster. Also you pay something for workloads. So that is what is written here. Okay, so in most of these you will see that the infrastructure cost and everything depends on the workloads you are running. Okay, but in case of OpenShift, the costing of control plane, again it is included, but so you don't have to pay extra. The subscription will take care of this, but there will be some of the extra services which you will buy from an OpenShift. For that you have to pay extra toward the subscription you have bought. Okay, but anything and everything is an add-on to that subscription, and I will just explain you once we move ahead with the actual services model. Okay, so licensing is done, control plane is done. Moving to the worker nodes here, again, as I said, you pay for each of them. You have to pay for the whatever workloads you're running. So this is nothing different here. So you are paying for this infrastructure plus some subscription cost, which I think we already said, right? So you already bought that subscription where you will be running some workloads, and that based on you are anyway paying workload plus subscription cost, so that remains same. And support, obviously everyone has their own support. Whenever you see community, that means it is only the I would say a free support from a community. But wherever you Azure, they are actually, when you say AWS, it is AWS plus Red Hat. Similarly for Azure, Azure plus Red Hat, because both are working together for maintaining the OpenShift platform on their clouds. Okay, so the public cloud providers and the Red Hat work together towards that. But if you have directly buy on from the Red Hat, then it is an enterprise grade Red Hat support you will buy, and you will directly interact with them for this particular platform. Okay, so from basics we just covered the basic layers, and what difference is if you build on your own versus if you buy something from Red Hat OpenShift. Okay, so again, I will pause here for a while before we move ahead. Okay, so now we have seen layers, but how, what are the services actually are baked in? This is what I will just increase its zoom it bit so that you are able to see it clearly. Okay, so if you see master versus worker nodes, these services differ because we have to have a control plane which is built on master. Hence, these services which you are see, this is common to whether you are using public cloud versus the OpenShift. The only difference is once you are buying from a subscription, you will have extra OpenShift services. We sometimes call it as a automation layer, which I've shown you above, which is already baked in. Other things I think you are very well aware of what a worker node requires. So that is what is shown here. The base compute network and storage remains the same for any infrastructure. That means you are building the machines. So obviously you will need three of them. Here the concept of control plane versus worker nodes is same as you have been working with Kubernetes as platform. Okay, so this is just to show you what is extra. So OpenShift services along with other things which are baked in is what is coming extra to you. Okay, as a part of which is directly built in so that you don't have to build the extra services on your own. Okay, networking and everything is set up including the DevOps platform so that you are ready to go on with OpenShift as a platform. Now, in spite of this, if you want to go on your own, okay, so basically you will choose on some of the services, or I would subscription model based on platform plus container platform and Kubernetes engine. Okay, so this is what you have to choose on once you install it on your private cloud setup. Now, moving ahead, I think I will again come to the services because this gives me a very good representation of what is included and what not. Okay, so OpenShift services, this is taken from the documentation. So you can also visit the documentation of Red Hat and you will get this particular bifurcation. So I will start from where we are. Okay, so this is what our infrastructure layer is. On top of that, as I told you, if you are running VMs, then you will know it cannot run on Core OS. It has to be enterprise Linux. So this is what you have to take care of. Okay, similarly, if you are hosting the Kubernetes, then you need some Kubernetes engine. So by default you will have your binaries if you are doing an open source installation on Kubernetes. Okay, and on top of that you will obviously have some of the cluster services built on. Okay, so ideally if you buy from OpenShift based on the pricing, if you are just buying the Kubernetes engine, you are only provided till cluster services. That means you are done and dusted with whatever is required for you to up and running, and basically the installation of your container platform. Okay, so you are done and dusted with that. But what about if you buy the complete platform, the subscription based on the complete container? In that you get complete platform services with service mesh baked in. You have a API already available for cloud native deployments. You have your developer tools. Similarly, if for AI ML also you have the data services in a catalogs already built in for you as a platform available to be deployed. Okay, so understand difference. We are starting basic Kubernetes engine to get you up and running. Then on top of that, you have a container platform which gives you a platform as a service. Still here you are on infrastructure. Remember, till here if you just buy this, you are on infrastructure. You have to have your own built up for running the platform like service mesh and other developer tools. You have to actually have your own, or I would say integrate with any third parties. That is what you look at. Container platform, everything from an OpenShift, complete platform run as a service. Everything is available from GUI as well as CLI to get you up and running. You don't have, in this case, you don't need any expertise required to build the container platform. You are good to go. But there are other services which are also top of that, which is the platform plus. Now this is not required by everyone, but I think if you really want to manage Kubernetes from the global perspective, then you have the global security, cluster security, global registry, multi-cluster management. That means this is more on if you are having a multi-cloud Kubernetes environment which you want to manage. Okay, so think of the complexity. You have OpenShift, you have other public clouds, but you want to have your own um, cluster management software. So that is what the platform plus gives you. Also, as you are already having huge the bifurcation across the clouds, so cluster security is also an important, along with the global registry, which you can integrate and have them access while you do the deployments. Okay, so remember, bare minimum, if you want to have a platform services, you have to go with container platform for buying. But if you are aware that you will not require that and you have the internal expertise, then you just go with the OpenShift Kubernetes engine. So this is how you buy the OpenShift. When I say subscription model, this is how you buy them and then you host them on your platform. Okay, so you have to pick and choose what exactly OpenShift services you want to run and accordingly pay for it. Now, again, as I did it for, I will just pause here for a while just to show you what you have as a OpenShift services. Okay, so moving ahead, what is meant by architectural guidance is, obviously we know the public cloud providers are providing us the OpenShift. Okay, but if you are hosting on your own, you should know what kind of an architecture will look like, or I would say a basic building blocks of an architecture, networking, storage, and how you will bifurcate. So that is what it is shown here. Obviously, in interest of time, I have just shown AWS and Azure, but there are other cloud providers also providing same. So you can refer to their websites. It will be equivalent to what we will show here. But from an architecture guidance perspective, at least if I provide you then how you built on Azure, how you built on AWS, you should be good to go ahead with the other cloud providers. Okay, so this is what an OpenShift hosting platform from the cloud providers available to you out of box. AWS, Azure, Google, IBM, and obviously Red Hat. Has its own dedicated environment which is hosted on AWS is Google, but it is not managed. You have to directly buy this dedicated from the Red Hat. You don't have to go with AWS and Google, or you can, I would say, in simple subscription model, you will have single vendor or SRE team managing your hosting platform of OpenShift. But here, as I have already, if you are going with IBM and Red Hat will manage that. If you're going with Google and Red Hat, similarly Azure and AWS. Okay, so just these short forms, I think you will come to know once you are working on these platforms. But all of them provide OpenShift in some shape and form. Okay. Now moving ahead, let's jump on directly to what the control plane will look like. Irrespective whether you are on public cloud or the private cloud, the basic Kubernetes structure remains the same. That is the reason I'm just stressing it again and again. Control plane requirements along with the worker nodes are have to align with Kubernetes requirements. And on top of that, actually, whatever you build from an OpenShift is an addition what you get from an OpenShift. Okay, so this remains the same, the way the APIs, way the orchestration process, similarly the networking, communication, and the storage. This remains the same in alignment to Kubernetes deployment. Okay, so again, I will pause here for a while so you look the core architecture requirements, or I would say a core plane requirement in simple sense. Okay, so now if you see for private cloud, first of all, you are having your in-house expertise. You need a lot of experts from networking as well as security for running this on operational. So this is what I have written. From infrastructure expertise required on the bare metal or hypervisor. From networking, you should know the people knowing the firewalls, load balancers, and how do you isolate even for networking stuff. For security, server data governance and the regulatory requirements along with the security policies is what you will manage. Scalability, obviously, if you are running your own private cloud, the capital expenditure and lead time to provision you should be aware of. So operational model, obviously you need to have the resources as well as the maintenance cost for that private cloud. But if you are directly going with the public cloud providers, they run on the pay as you go model. Similarly, you also need to make sure that wherever you go, I think your team has an expertise on that particular platform. Or if you don't want anything from them, I think you can directly go to Red Hat and have the platform as a service platform, in case you don't have an expertise for that. Okay, so this is what architecture guidance I want to give you. And now we will go ahead with how this architecture will look like. Say, suppose if you are hosting on the Azure. So for Azure, the bare minimum layer is creating first of all is creating these subnets. Okay, so you need to have a VNet where you will have a spoke as well as hub network, and then slowly you will build on your worker, your control node, and the whether you need a private endpoints or how you want to access from an external world. So these things will come slowly based on your expertise on or your team's expertise on these things, and from an on-premise access as well, how you will allow these with the help of best and host, how you want to have your gateways. uh, so these all things you have to do on your own while you have this platform built on Azure. So this is just a sample. You can have your own services as well at the bottom. I have just shown you whatever max we can show you in this diagram, but I think consider this as a sample architecture. Building on top of this, if you are going with an Azure, what you are doing in nutshell is private deployed across AZs. Then you are integrating with an for identity and authentication authorization. Then you have a web application to connecting to the external world, accessing this ARO with some kind of web available to you out of box. And then firewall for outbounding traffic if you want to access that. Bastion host, obviously, Bastion host is required for as a jump box to get access to the machines so that you can manage them in and out. And finally, you want to have some kind of either you go with the OCP, that is OpenShift monitoring platform given out of box by OCP, or if you want to have it logs through the log analytics, then obviously you have to install the agent on this before you can actually have the log analytics workspace running on this. Okay, registry use either OpenShift or ACR, have the certificate, or I would say a key value pair along with the certificates. These are some the services which you can. I've just shown these optional services, but bare minimum you will need these. Okay, so ensure while you work on these particular installations on your own, your team is very well aware of these small basics right from the networking and setting up the nodes, having them harden, uh, and then according to whatever the Kubernetes platform you're trying to build, have the appropriate networking, or I would say a platform built around that before we can run the containers. Okay, so this is for Azure. I think this is a sample architecture available on the Azure also, so you can refer to that as well. Okay, now similarly AWS has its own services. So again here I will just show you. Again, this is multi-AZs, and it will also have some kind of subnetting. Okay, so you have a load balancers, transit gateways. So this is the networking part, but how we are accessing to our internal or integrating with the external world, how the team will access this, how the client will access this. So this is what a basic networking diagram, just to give you a overview of what the architecture will look like if you do a private installation, private cluster OpenShift installation on the AWS cloud. Okay, so in interest of time, I have just shown you these two diagrams. You can also refer from an IBM or Google. They will have similar kind of an architecture if you are deploying on own. Remember, with OpenShift, it is not just your cloud provider. You have to buy a subscription from the OpenShift as well, based on whatever services I have shown you. Okay, so remember this model, this services, this is what you will going to buy depending upon what your needs are. Okay, so with that, I think we are done with the architecture guidance. So now let us look into the how we will set up our lab environment. Okay, so from Red Hat, I think they are giving you a sandbox environment, which I think by default will be available for 30 days, or I would say 1 month of time. So you to try out. Okay. So where you have to go is developers.redhat. Just search with the sandbox. I think you will come to this page. Okay. And you have to click on start uh, your sandbox for free. Once you click on, if you already have the Red Hat login, you just go to that login, and then the sandbox step-by-step instruction will be provided. But if not, I think you will just set up the Red Hat account first. So this is the instructions you have to put in. So how we have started is, first of all, we have just click on sandbox for free. Okay, go on to the search in Google or whichever that sandbox for Red Hat. I think you will get to this page. Then start creating your Red Hat account. Put on your login details, password. So this is how you will get started. So once you do this, sandbox will be available to you immediately. You don't have to wait for any approvals or anything. This sandbox will be available to you out of box, and this will be for 30 days. You can try free of cost. Okay. Now once you do this, the what we can show you here is from how do you launch the actual OpenShift console. Okay, so if you see, once you log in, you will get try it. Okay, so I have this already open with me. Okay, so I will just click on that console. So just give me a moment. Okay, so this is the console we have. So what we have, once I launch this console, first thing is this dashboard. Okay, so we by default I have this project created for me based on my login. Okay, so this was my login, and then -dev is what. Then in this particular, what I have is this particular dashboard, which is giving me some kind of inventory I have at this point of time. Okay, and currently if I'm running anything, I think it is clearly showing me that particular. Okay, so this is the GUI, you can say. So you can also go to home, click on projects, you will see the other available to you out of box. Okay, so if I click on this is where I will come here, which I have shown you. Okay, now let us get start with the actual what labs we want to do. Okay, so how we will divide the lab will be, first of all, we will try to see the one installation from the GUI, one installation from CLI, and then finally we will do the database application and database installation together. Okay, so these are the three labs, and finally I will show you how we actually convert the deployment config to the deployments, uh, and how this template will change. Okay, so ideally we have four labs, out of which two labs will be straightforward. The third lab, which will be actually the application and database deployment, and the fourth lab will be actually conversion of the deployment config to the deployment. And then we will finally close our session with how we can complete the other labs on this OpenShift sandbox. Okay, so now let's get started first of all on where we are with the what kind of the, once you are actually logged in, so this is how you will see your environment. Okay, so if I see the OpenShift and the developer sandbox, it will give you an overview of what exactly you will get into. Okay, it will give you an overview of web console. I think you can go on your own for this particular. What I want to show you is the labs which you will do out of this, so that you are directly, similarly is for CLI. So for CLI, let me choose on to show you how this will look like for CLI. So let me try to, so this is the GUI. CLI, just the way you have in other cloud public cloud providers, they are also providing us the. But remember, while you click on this, this will, that the terminal will start, try to connect and will provide you the CLIs. Now this issue you will face because the currently this is also running as a part of the pods, or I would say running on this particular sandbox. So it will take some time to start. So the moment I click on the other terminal too, if you see we are already there. Okay, so if you see this error, make sure, I think either you close it and restart it again, or you start the new terminal, whichever you feel. Okay, so with this, I think I want to show you the first thing, which is OC get pods, to show you that our workspace, now this workspace nothing but our pods running in this particular project. Okay, so whatever I have started this CLI, this is also running as a pod. Okay, so now moving ahead, what I want to show you here is, so let me close this off so that we have some space. uh, so what I can do from here is, first of all, let us look at the lab. Okay, from where we will start. So one, I will start with GUI. So let me go to the GUI. So this is available in a sandbox. The reason I'm, the two labs or whatever the code I'm using this same, because what we want to do out of box is so that you are very well versed with how you are going to access these labs, first thing. Second thing, there are challenges. These labs whatever they're given are old. I think if you see they are 2023, so few will run directly, but there are challenges in some labs. So especially in the first lab which we are doing, it will not run directly. So how you are going to get over this error is what I will show you in this particular lab. So if you see, while you log in to this, you have to come to the topology, and from catalog you have to actually search for Python and do the Python installation. This is an application which we want to install. Okay, so how we will do it is, basically we have to convert source to image. For that they have given us the GitHub repository. Okay, now let us see how we do this as a part of. So I will just copy this because I will need this. And remember they what version they are saying, UBI 8 or 3.9. This is what we will search in the catalog before we install from the GUI. Okay, so I'm just coming to the, so from here I will just expand this, come to the workloads. Here you will get the topology. Okay, as of now, as I said, workspace is one particular pod running for us. Even two pods running for us for this particular terminals. Okay, now what I want to do is I want to deploy a project from catalog. Okay, now in this catalog I have to search Python. Okay, so this is what is the builder image which you have to click on. Okay, 3.12. The moment you click on this 3.12, it gives you some basics of what it will. So just read through. It will have the build configuration, image stream, deployment config, and the service. Okay, and create a route for you to access that. So make sure you go through this, what the template is providing you. Now moment you click on create, okay, it will show you the again the GUI for installation. Now here first important thing is we have to, now this is what I was saying. If you go directly with this latest image, I think it is already broken, or I would say the image installer has gone through versions, so your actually lab will not work. So they were asking us to go through 3.9 UBI 8, but here what we are seeing is 3.12. Okay, so what I would say is you go through any of the images. If you don't want to like directly go to 3.9, you start with at least 3.11. Okay, so where you will be able to at least get some latest images, and then it we have to pull from the GitHub. Basically this is nothing but they have the Docker files there. With the help of this they are going to build whatever you have seen as a while we restarting, and then you select the application name. I think you can keep any name you want. For simplicity I will keep it same as it. And finally the deployment type which we have is, we have three types. One is a serverless deployment config, so I will select deployment because this is what we are doing. We are going with the deployment, and by default this will be selected, the route will be selected. This is to for you or the services which are exposed accessible to us on the web or over internet. Okay, so I will just click on create. Remember what we are doing here is we are creating a source to image application. That means the code is there in GitHub, and we are going to run this code and have the application running. Okay, so with this, I think resources are added, but if you want to see at here, you will be able to see that builds are running. Okay, so our build is running, and services are created, routes are created the way we want as a part of, and this is the deployment. So once our deployment is through, I will just show you the other things which we have to take care of. This will take some time. Also, in meanwhile, I think I will show you the logs. It can be slow sometimes, but I think it will load. So currently it is pulling out the image. Okay, and this is exactly same to what you see on your Kubernetes CLI or kubectl while you do any deployments, right? So this is what it's trying to build on, and it will actually get into the full deployments what you have seen. Again, coming back to this particular installation, what you can do is while you click on this, I think it will show you the details, which is this particular deployment. and clicking on this deployment, you come to this deployment page. Okay, so details are the pods, namespace. This is what you can see, image. Okay, the basic stuff. I think similarly, if you want to go through the YAML, you can also look into the YAML what this deployment is looking in the form of YAML, whether you have replica sets, pods, and what kind of the environment variables or environment you are trying to set up. So this will give you idea of that. And finally, the events is nothing but what all the running uh, whatever the deployments are going on, creation of the services, pods, everything will be provided on top of this. Okay, so coming back to the deployments. Okay, so this is what you see. Again, coming back to the topology. So with this green check, I think our service is ready. And if I try to launch it, let me try to launch it and a URL. Okay, so this is ready for me. Okay, so so this particular application is running. Okay, so again coming back to our lab, what we have seen so far is from this particular deployment, first of all we can check the pods, builds, services and routes, four things. Now how to also check on the CLI? Same thing, the way you are running. So here I will just put first of all pods. Okay, so we are running these pods. Then I want to check services. Okay, you see this block Danjo services running, and finally our route. Okay, so this is the route we have. This is actually the URL which is publicly available, which we were currently targeting, for which you have seen the application. Okay, so this was the basics of any application which you run as a container. Okay, now moving ahead, this again this simple application, what we will do is we will just have a look into other application, but now this time we will have directly deploy from CLI. Even though these are simple, but if you as the labs are getting updated day by day, you have to select a right image uh, and then accordingly move on with that. Okay, now one thing you will see by from the CLI is they will ask you to have the token. Okay, so now I think this is very small. Again, if I can, so while you are logged in, I think you can have this display token. While you run this, I think I will show you here. So you can click on copy logon command. Okay, so while you do the copy logon command, it will ask you to show you the display token, and then you use this token in CLI. That means something which is installed on your machine to authenticate to the API of OpenShift, and so you get the authentication to the API server. But coming back, I think currently what we want to do is we want to just install the this particular using CLI. So what I will do is rather than going to my local computer, I will show you this deployment on the OpenShift itself. Okay, so here let me clear the screen. So I will also expand this bit. Okay, so what I will do is I will create this new app. Okay, and we'll try to get the application created. So again, looking to this, I think you already see you have this icon created in topology of greater, and add currently if you see this is just the deployment. That means I just have the services. It is still not exposed to the actually I will let me show you how you know that whether this is exposed to the internet or not. I will okay, so anything like this which does not have this icon open URL something, it is just running internal to the cluster. You're not exposed to the external world. But if something like this is exposed to the world. So for greater also it is not exposed. So how you will check that One is using your UI, another is using the command line. So if you see, we only have the previous application which we installed. We don't have this services export. So let me uh, create the route for that. So what I will do is, first of all, I need to know the services for this. Okay, so I will say OC get services, which will provide me the service which is running, which is greater. Now I will try to expose this OC expose service. Okay, then I will give the service name, which is greater. So I want to expose this so that I should be able to access this over internet. So if you see, route is created. Now let's check this route is created for us. Now this route is there. Okay. So remember, while this route is there, I can again go on, just minimize this and try to open a new window. So this is what you have. Okay. So now this even though this team, this is very simple, but I'm just trying from a from the someone who's starting fresh, how you will navigate this and actually get the labs done. That is the reason at start of this particular session I told this is for beginners and intermediate. Now from here onward, what we will do is for intermediate audience who already know some basics of an OpenShift, and this will set your platform for doing anything on your own. Let it be your own service deployments, creating your own templates and everything. If you now on from here onwards will go to bit deeper into the deployments. Now these two applications, one through CLI and GUI, are just very simple, which is available in your sandbox and how you deploy them. Okay, so at this point of time, again you can go and check them. uh, you have running pods, services, routes, everything is there. Also you can check what kind of the resources they are consuming at this point of time. So this is something you can do. If something is going wrong, you just go and check the logs. Okay, so I would say wherever you are, and just have this logs, uh, and go through them. If something is not working for you for troubleshooting, put those particular errors on Google for searching, or maybe if you are aware of that, you fix them. If it is an image related issue, you try to fix that image. If it is related to configuration, you have to see your YAML files. Everything here is same as what you have in Kubernetes. Right from pod, services, deployment configs, whatever you see, they are baked in as YAML deployments, which you are directly deploying here out of box. Okay, so starting here, starting fresh, again, this was a second deployment which we did as a beginner or fresher. Okay, now let us try to deploy something which will have an application and the database. Now for that, again I will use my CLI. Okay, so the important why I'm using CLI is because you should be aware of the commands as well. Okay, while you do the deployments. So let me do the deployments. So what I will do is, first of all, I would say let me clear these screens. And how you clear this is click on this application. It will come to right side and delete the deployments. Okay, I can do from CLI as well, but showing you the once we complete this at the end, I will show you even through the CLI. But as of now, just clear this topology so that we have space for other applications to be deployed, at least for visibility per se. Okay, I'm not saying that you won't be able to deploy. You can keep, but it will be all messy look. Now I just have this workspace because I want this. I'm running the CLI from this. Okay, now let me start the third deployment. So from this I will pick up now one deployment I pick up as a GUI, one become my view as CLI. Now let me pick up the one which is from the, let me pick up something from the database. So I'm just looking to the last working with the database. Okay, now this is what you will see after deployment. And what we are doing here is we have an application and we have the MongoDB as a database. Now application will actually get the GUI and get the random names and save in the MongoDB database. Okay, so but for you this is an app plus database model which you want to deploy. And if you see, the web page is hitting the API server and getting the information from database URL. This is all available to you while you are on Sandbox. I am just going fast so that we are able to complete our labs on time. Okay, now let us get started with the this particular lab. Now first important thing is we don't have a MongoDB in our catalog. Okay, so while you see, I will show you from catalog where I'm saying. So as of now, if you want to create the template, this is the command you will have in your. So again, let me clear this out. Okay, so I'm just making it very visible. So this is the command which I will be having to create the template for Mongo so I can deploy it. Okay, so I can deploy the application from that. So if you try to create, I get error because this is already, I have already imported this. Now where you will check this, I will go and check in catalog. So if you will do on your at first, I think you will not have any template, so you will not get this error. But while you click on the database and click on, you will not find any Mongo template here in developer sandbox. So once you actually go through, this is the template which I was talking currently, which I have just run command for. This is already available to me. Okay, for deployment. Okay, now you can directly instantiate this template through the GUI and have these namespaces and everything populated, or other ways to go through CLI. So I find CLI fast. That is the reason I normally go through the CLIs. Okay, so again coming back to our topology. Okay, what I will do is following this particular. Now this image, if you have already done the deployments, I think you will have this, but if not, I think you can also have to run this. I will again get the error here saying that this already exists, but let me try this out for you because I am already doing the lab. So I think they are already present in my sandbox. Okay. So this image is already there for me. Okay. So this is how it will look like. Okay, so it will be imported into your in your and where you can see this, you have the image stream available to you. So let me check here in our deployment configs. So you have within builds, click on image streams and you will find the MongoDB available to you. Okay, so this is how. Similarly, while you build anything, the build configs and builds will be also created for you. Now I have cleared the deleted them, hence they are not available. But once we deploy, I think I will show you them. Okay, now coming back to the topology, and let me clear this again. So what I want is I want to go and do this deployment for MongoDB and an application which will create this random name generator. Okay, so first of all, obviously you will be logged on and select this template which I have shown you out of box, and this you go accordingly. But what I want is I want to have this particular installation done through the GUI CLI. Okay, so for that I think I will select the CLI. Now I already have the CLI with me which will deploy this for me. So I'm coming to this particular terminal and selecting the command for the deployment. and this deployment will be creating the new app, uh, which is nothing but from the template. Okay, so I will just paste it into the terminal. Okay, so I have this CLI created, which is going to template name, then parameters. I'm putting password, then MongoDB database name, and then obviously the namespace. So once I click enter, it is actually creating the MongoDB for me. And out of box, what I get is, as of now, a database is created with a name and the secrets. Okay, and to also have the services. So how can I get that? Again, you OC get pods, it will give you what exactly it is. Currently it is have created MongoDB. Okay, pod is running. Similarly, I should also get service out of this. So MongoDB as a service is also running. Okay, so at least I know this application is now installed. Okay, now the other once the database is done, the other thing I have to install is an application. Okay, so database is done. Now I want to have the application created as well as connect to this database. So again, I have a command line which I have already created, and this application, and this is not something which this is available to you in this developer sandbox. Just to speed up the things, I'm just already have this ready with me, so that you don't have to go through the complete reading through. Okay, so I'm creating a new app which is name gem, and it is going to have the environment variable, that is, this is nothing but the connection string. Okay, so you have a MongoDB, uh, then you have a gen user password hitting the MongoDB service, and then finally creating this. Okay, so what want to do is actually create this application which will now connect to the MongoDB as a database. Okay, so as of now, if you see, this is creating for me, and it will take some time because it has to have the build completed. So let us look at its build before we move further. Okay, so ignore these errors for some time, because these are some resource quotas. It will have to unless, because we are running so many things, sometimes you will get this error, but I think you should be able to overcome this. So as of now, our build is running. Okay, and you can also check the logs of these, what exactly is going at this point of time. Okay, so this is trying to create the build, image pulling and creating of the containers is going on. Okay, so again, we can come back to our topology and look to that particular application. Okay, so we'll wait for this to complete and until our pods are created. Okay, so I think we are there almost. So we have our pods here, we have build, we have the service, but we don't have route. That's correct. We want to expose it once we see that there is no errors for this. Okay, so also what we can do is we can confirm on the CLI. So what I will do here is I'll clear this OC get pods, for seeing the pods are there for name gen. I see it is running now. Similarly, I would say whether my services are there. Okay, so name gen service also there. Now I can go and expose or have a route OC expose service slash name gen app. So this is the service name I want to use for creating a route. Okay, so now route is created for that. So how we are going to browse it, as you have already seen, it will have the icon to open URL on top of this. So I will just click that and I have this app running. Okay, now I will get the random names, try to save them in database, again get some random name, again trace app. This will keep on adding until I clear them from the database. Okay, so I'm just trying to get them, save them, and again clear them. So this is what the exercise you can do. Now, important thing what we did as a part of this deployment is now going through the template. What this template, as I said, this is for an intermediate audience who is above the beginner. So now you should be aware of how to read the templates and what are the different parts. So let's move on to that part and see what. Now we are just completed one deployment, which is app plus db. Okay, it is running. Now let's do the reverse thing and understand what those particular template means to us. Okay, so now I have this particular template of deployment config which we just deployed. Okay, I will just increase the font so that you should be able to see that. Okay, so this template is the, this is how the annotations we have. Even I would say the schema look like same the way you have in Kubernetes. So till till here I think I would say this is more of the metadata going through. Okay, now this is how the messaging part, labels, labeling is there. But our main job starts from here, from an objects. Okay, so let's see what we have in objects. First thing is what we're trying to create is a secret. Secret for what? We want to have database admin passwords, name, and then username along with the databases stored as a part of string data in this secret for MongoDB. Okay, now this is the first thing. And I am passing the parameters. I will show you where these parameters are. Other thing what we are trying to deploy here is a service. Okay, because the pod is going to hit the while you browse, I think database is going to hit this service, but behind this service there should be something running, for which for that we have this deployment config. Okay, now this deployment config is the actually your database pods which you are seeing. Okay, and then at last you will see these parameters, how we are the as I said, we are passing these parameters either to CLI or to GUI. So that is where is, so this is how you read the template. What are you trying to deploy? Okay, so as this is a template, we have combined more than, I would say, 2 to 3 of the services, pods, even the secrets. Okay, so you have the components of this which are seeing as a deployment. Now what we want to do out of boxes, this is part of your sandbox. Okay, so that is available to sandbox. Something which is not available in your sandbox is how do we convert this deployment config. Okay, we want to convert this deployment config which I have shown you. Let me come to that. So this is the deployment config and this is deprecated. Deprecated means this is not for production, you cannot run this. And how you will check that? One is there here. Again, you can directly go to the MongoDB and click this. Okay, once you click this, you will get a warning that now this is not supported. So how do we convert this to a deployment? So that is what is our next lab is. So what I have done is I have converted this deployment config template to the deployment template. Now, if you see how that will look like before we actually do our next lab is go through this template. Okay, so I will just show you how this template is created and what are the things I have changed. So if you see, this all remains the same. This is more of a information or messaging, I would say. Parameters is which was at the bottom. I've just brought it up and have them as my first part. to define these variables, and exactly the same thing which what I'm just rearrange this template so that this looks neat and clean. Second thing is I want to have secret again. I've just removed the any messaging and everything so that it's look clean. These are the four things which I want to store in secret. This is the second object I had. Third thing is a service. Now this is a service again. In our previous template, if you see, we had the service first and then deployment config. Okay, so this is a service. Okay, same thing, I have changed it for deployment. I have just given in some structure so that looks bit clean. Okay, and I'm naming this as a MongoDB deployment service, and it should have the pod or the deployment having by name Mongo deployment. So again, the converting the deployment config, this is the main part. Okay, so just make sure you understand this part. First thing is changing the deployment config here. Okay, I'm just let me come back here so that I should be able to. Okay, here it is. First thing is changing this kind to deployment. Okay, so which I did. API version, apps version 1 is what we had to have. Similarly, there will be a selector match labels. In deployment configs, you directly have spec and then selector directly naming it. But for the deployments, you should have a match label. So this is the third change you will see. So here you will directly see spec selector. Okay, and directly the service. But here you need a match labels for what deployment it is. So these are the some changes which you have to see. Another thing is you have to remove this complete image trigger part. I'm just coming to that. You remove this complete trigger part. We don't need in the actual deployments. So I don't have this in my. Okay. So once you do these changes, 3-4 changes which I have seen, at least you will be able to convert your deployment config to the deployment, and rest all volumes and how you actually have your resource limits, ports, environment variables, everything remains the same. I have not changed to this. Even the strategy types remains recreate. So I have not changed this template. Now I have saved the old template to the new template by naming the MongoDB deployment full template. Okay, now let's try to deploy this and see whether we are able to succeed in getting the deployment uh, done and have this error. We don't want this error to come. We want to have the latest version. So this is not in sandbox. So this is the reason I've told you. This is for intermediate audience who wants to go above to what for your production environments. Now, first of all, let me clear this out. What already have, and then again I have my command lines created, and I have the catalog, this template. I have already uploaded this template. Okay, so this is available to me out of box. I will show you this first before we actually deploy this. So if you click on the database and click on Mongo, so this is what was which is provided in developer sandbox. This is what I have created. So the difference is I have just modified few things, and if you see, try to create the instance template, I have tried to have them exactly same thing. And if you see now, it is showing the deployment secret and service, whereas the previous template it was showing deployment config secret and service. Okay, so this is a change. You can directly go through the GUI, but as I said, I just want you to have hands-on on CLI. So I think we will go through the CLI again. Okay, so let me come back to the deployment, and I would have the deployment. Okay, so as I said already, the template is uploaded. I don't need not upload the template, but in your case, if you're doing first time, you just have to create OC create and that template file, OC create -f the template file. You should be able to upload that. Once you've done that, I think this is pretty much straightforward. Exactly, again, I'm doing the template. Now this is MongoDB full deployment parameter, exactly the same which we had done in the last lab. The only difference is in templates now we have a deployment instead of deployment config. So let me check if we are able to do this installation. Okay, so this is quite natural. We already have the secrets existing, so that's okay. Service created, deployment apps created, because I'm using the same secrets for both of them, so this is the error, but we do need not worry about this. We should have the deployment running with us. Now how we can check that? Let me first of all clear this screen and expand OC get pods first of all. So now I should have the Mongo first deployment and also the pod. This is our first which is with the deployment config. Now this is our new Mongo deployment which is running the second. Okay, so at least I have these pods running. Similarly, again I can get the services as well. There should be new service for this complete deployment. Now this deployment service running previously which we created was MongoDB. Okay, also you can check from here as well. If you click on to your deployments, I should have the pods running and the deployment service. Route anyway I don't need at this point of time. Okay, so so far good. I think we are able to move ahead with our new template to create the deployments instead of deployment config. Okay, so next part, we are done with the database. Let us create the application. Again I have a CLI created which will try to deploy this. So I'm just pasting this CLI. Okay, so I have this new name gen and name gen deployment. I'm changing the name this time, and environment URL is our new database, which is MongoDB deployment service, and then name gen is the. So let me try to create this new app. Okay, so as of now, it created the image stream, it did the build configuration, deployment service and services, and we are seeing the success. This will take some time, as we have seen in previous exercise as well, that it creates the build and then it tries to have the container running on this. So as of now, build is running, I see. And once it is done, I think we will create or expose this service to the external world using route. Okay, so let me wait for this particular build to finish. Build is at least complete and it is getting, I think even pod is now running. So let me check if this pod is available to us. Okay, so now I have the namegen deployment pod running here, not this, sorry, this is build, this running. Okay, now again I will check the service also is healthy. Yeah, finally I think we need to expose this. Name was namegen deployment. Okay, now I see a small icon showing me where I can open the URL. Let me try this out. So same thing exactly. We converted the deployment config to the deployments and this should work. Okay, so I am running this now from the deployment and our error which was there previously, let me show you that as well. That should have gone by now for at least this deployment. So if you see this namegen deployment, I am not getting any error here that this is deprecated. Where I am coming back to the the old one from, sorry, Mongo. So if you come back to the Mongo, which was deployment config, I'm seeing the deployment is being deprecated. But if I see this as a Mongo of, let me zoom it so that I can. So okay, now this is MongoDB deployment. I don't see any error here. So I think we are pretty much done with our part of creating the new template with the deployment instead of deployment config and running this service. So team, this is not available. This conversion of template is not available in the sandbox, but I have just shown you so that you should be able to create your own templates and deploy this out of box. Okay. Again, coming back to our what we have done so far is, okay, so we have launched this from our agenda. I'm just coming back to agenda to conclude this session. What we did was we did a comparison of OpenShift platform. We did an architecture guidance. We did set up the developer lab, which is nothing but sandbox. And then we did 3 deployments. One was with the GUI, another was with the CLI, and then we did a application with the database, which was having a deployment config. And then we created our own template from what was there in already existing template. We converted all the deployment configs to the deployment, and then we converted the some selector labels, and then we saved that template, uploaded that template in the uh, sandbox. Once we are done with that, I think we were able to deploy it. Monitoring issues and remediating is I have shown you. You just have to go and see the logs. Okay, and whichever the error you get, whether you are not getting the image, try to fix that image. If there is some configuration related error, try to fix the YAML. So that is how you will go to this particular. And final closing is what I would say is, this session was for a beginner and intermediate audience who wants to get started on OpenShift. There is a lot more to do. Maybe if we have we can get another session which is deep dive on any deployments. I will keep you posted, but at this point of time, I think this was our session getting started on OpenShift hands-on lab. Thanks.